Hello and welcome. In the previous episode, we discussed installing CentOS on Hyper-V. I have provided a link to that video in the course description. But if you already have one or more CentOS ready to go, then you don't need to install anything else and just follow these instructions. In today's episode, I will go through the step-by-step installation of Docker and Kubernetes on CentOS. By end of this presentation, we will have a functioning multi-node Kubernetes cluster. Here's the agenda for today. We will need to install to perform a number of tasks. Some of them will need to run on all nodes. Some of them will need to be run only on the master node. And some will need to be run on each node. We also need to test to make sure that everything is working as far as network is concerned. So let's go through that one by one. Under all nodes, these are the tasks that we need to perform. We need to open all required firewall ports that will be used by Kubernetes. There's also a number of configure security requirements that we need to do. We also need to configure required network settings. We will need to install and configure Docker. We'll need to install and configure Kubernetes. And on the master node only, we need to actually initialize a new Kubernetes cluster. So we will be using a handy utility called kubeadm that will make this task a lot easier. We also need to install a network plugin. Frankly, Kubernetes networking is a little bit complex. And I'm hoping to provide a course on that in the near future. But for now, just remember that we need to realize that we need to install a network plugin for the pods to be able to communicate with each other. Kubernetes has provided a basic white paper or how this communication should be done, but it doesn't provide it out of the box. So there are a number of providers. One of them is called Calico that provide that functionality. And this is the plugin that we will be using today. There are other ones that I will provide a link to so you can look at them and decide whichever suits your purpose. Then on each node, once we have the cluster set up, we need to run a kubeadm join on each node to be able to join to the cluster. Then for testing, we can run commands either on the master or any other nodes to basically to ensure that the cluster is up and running, all the pods and nodes are able to communicate with each other, services can be created, and we will do that by deploying a new pod that will help facilitate the cluster testing that I mentioned above. In terms of prerequisite, obviously we need CentOS VM, one or more. So if you only have one VM, no problem. We will make that work with just a single node. And then in the future, you can expand it if you need to. For each node, I would say at least 3 gigs of free RAM and 40 gigs of disk space. This is really minimum. If you are planning for a multi-node cluster, then I would recommend assigning the VMs static IP addresses. I would also highly recommend setting up NAT or network address translation. I have discussed setting up NAT on Hyper-V in one of my previous presentations. I will provide a link so you can follow that. So enough of talking, let's get to it and start installing stuff. So we are in Visual Studio Code, and that's where I'm going to run these commands to set up our cluster and join nodes to it. But you don't have to run in Visual Studio Code. I'm just running it because it's easier for me to demo. As you can see, there are 3 tabs here. Each one corresponds to the commands that we need to run for various purposes. The first one, this is the code that needs to be run on each node. And these are the things that you need to be set up on each node. The tab in the middle is we use when we want to add a node to the cluster. And the last one is the commands that we're going to test the cluster. So let's get started. Let's SSH into my first node, which is the master. So I'm going to put my password. Okay, and then the first thing that we need to do is open a few firewall. Let's run it as the admin. Okay, so these are the firewalls that are needed in order to the cluster function properly. We need to open those. I also added the ports between 32,000 and 32,767. And those are the ports that the cluster will use in order to expose itself to the outside world. So it's called node port. So if you want to access the cluster from outside the cluster, you have to use what is called a node port. We'll get into that later on, but I'm just going to open this in anticipation that we will be needing this in the future. The next one is we need to also add the nodes that are connecting to as part of this cluster. We need to add them to the trusted zone. So all communications will be allowed from these nodes to each other. You can add each node separately, but I'm just going to add the cluster, the subnet, which all these nodes reside. I'm going to add a subnet, so you can either add the subnet or each node separately. So it's easier if you trust that subnet, add that. And the last one is we need to masquerade. So, and the last two are actually very important, and it took me hours and hours in order to figure them out. So you need to add your node to a trusted zone. You also need to add enable masquerading. So what does it mean, masquerading? It means that when the pods are created and they need to reach the outside world, they will be running in a network which is internal to the cluster. So they don't have any visibility by default to do anything outside the cluster. Masquerading allows those containers or pods to use the IP address of the node, whichever node they're running on, and kind of masquerade that and use the IP address, kind of masquerade the IP address of the node as if it's their own, and that will allow them to connect to outside world. This is really behaving like NAT, network address translation, and that's exactly what it's doing. They'll be able to use the parent, which is the node's IP address, in order to be able to connect to the outside world. So let's run those. Okay, that's done. Now, next thing, we need to enable net filter. And net filter is used to do all kind of packet filtering, NAT operations, and port translation. So it's important that we enable those. So let's enable that. And then we restart firewall to take those into effect, and we exit. So that's as far as all the firewall rules are concerned. Now the next step is, because we don't have a DNS, so we need to add each one of the nodes on each node. We need to add other nodes into the host file, so we can have network resolution or DNS resolution. So I'm going to open the host file, and I'm going to copy. So this two needs to be added to this file. So copy, and we paste them here. Next step is now actually setting up a Docker. So Docker used to be used to be included in the repository of Red Hat and CentOS. Unfortunately, it was taken out in CentOS 8 because CentOS and Red Hat now provide their own container management is called podman. So we have to add them manually. So this is what we do. So run on line 29, we add that to the repository. And this is on line 32. We are going to actually install Docker. So when we run that, it will install Docker on this machine. So I'm going to run that. So Docker is installed now. And on line 35, you're going to start Docker. So let's go ahead and do that. And on line 38, because we ran that as administrator, only the admin is able to run a Docker, because otherwise we have to run sudo each time. So we're going to add, whoever is logged in right now is me. I'm going to add that to the Docker group. And then that once we exit, which means that log off, log back in, then we don't have to run sudo for each one of the Docker command, like Docker run or Docker find a version. Those can be run as an ordinary user, not the administrator. So let's exit on line 41. We exit the server, and then we log back in. We do SSH again into the server in order to command to take file. Okay, now we do, just to make sure that Docker is installed correctly, let's run a couple of Docker commands. Let's run version. As you can see, this is the version number. And also for good measure, let's run a container. Let's download the container and run it. So it's going to download the container and then run it. And everything runs correctly, so we are good to go. So that's as far as testing the Docker is concerned. Now, once we install, we need to install Kubernetes. So before doing that, we need to actually create a repository for it. So let's on line 49. I'll just put my password again. So we'll add this, we'll create a new file called Kubernetes.repo. So we're creating a new repo because it doesn't exist. So let's copy and paste all of this. We put it into this file and save it. Okay. Now that we've done that, we are ready to install Kubernetes. So let's go ahead and run. So let's see what we are installing. So sudo dnf install -y means accept all the yes to all the questions. So we are installing kubelet, which is a CLI that runs on each node. kubeadm, that's a utility that will enable us to set up cluster. And kubectl is a CLI that runs on the client, so you're able to actually connect to the cluster. So let's run that. So Kubernetes is now installed. Now, one thing that we need to do before we start the service is we need to modify the kubelet on line 62. We need to open this file and do a modification. Let's see. So there is this arguments right now is set to nothing. So we need to change that. We need to add this argument. This basically forces Kubernetes to use the C group, which basically is used to manage resources. So we need to do that. Otherwise, it will fail when we start to run it. So make sure that you add that, modify the kubelet file, and add this to it. Okay, now we can start kubelet. So let's go ahead and get that started. Next step is we are going to have to suit to the root, run as root, and then create a file to configure the IP table. So this is necessary. That will basically force the traffic to go through IP tables. So let's go ahead and do that. Let's go and run as admin, and then open this file, which is empty right now. We're going to add these 2 lines. So netbridge, NFL call, and then one for IP4 and one for IP6. So we'll allow traffic to go through the IP tables for both IP4 and IP6. Okay, that's done. Now we just reload the configuration for the change that we did to take place. Okay. And now we need to disable swapping, because that's not supported in Kubernetes. That needs to be set off. So this is for immediately it turns it off, but it doesn't permanently turn off swap. So we need to actually modify the fstab file. So inside that, there is this line here. We need to disable that. So this is dev mapper cl dash swap. So that needs to be commented out. So make sure you do that. So that's done. Okay. Next step is we need to create a Docker daemon file in order to create a systemd for it. So let's do that. So we create just a JSON file, basically. So that we need to modify that because this is required, this modification is required by Kubernetes. And once we do that, we need to create a systemd file for it. So that's on line 97. So we reload the daemon. We also restart Docker. So we need to do that on each node. So you can pause here, and I'm not gonna repeat that for other nodes. And so if you have other nodes, just go ahead and maybe pause here and run this in all your other nodes, and then we continue. So at this point, we should have all the nodes configured with Kubernetes and Docker. And the next thing that we need to do is log into the master and initialize the cluster. So on line 1, I'm going to SSH into the master node and put in my password. Now I'm logged in. Now I'm going to run a command called is sudo qadm init, and that will initialize the cluster. Let's run that. And my password again. And it starts initializing, and it's going to download a number of containers in order to initialize the cluster. So I'm going to pause here and then continue once this is completed. So the cluster was successfully initialized. As you can see, the message is here. And then it tells you what to do next. So these are the steps that we need to take. And I already copied those up here. So for clarity, but make sure that you follow this, especially this command here to join the cluster. So let's go through that. First, you need to create a folder called cube. Let me just clear the screen. So we need to create a folder called cube that is under the home. And this is where the config file for connecting to the Kubernetes will need to reside. And then we need to copy config file from etc cube Kubernetes admin.conf configuration into that home .cube that we just copied. And basically what it contains is when you set up the cluster initially it creates a config file for the admin. So admin is able, now we have one user admin that is who's authorized to connect to Kubernetes. So we copy that to the home directory under the user which is logged in right now. I'm just putting my password. And then so that's copied, that config file under our queue. So we need to do that on each server. I'll show you how to do that next. And then we need to take ownership of that folder. We need to transfer the ownership from the admin to the logged in user. And on line 10, we need to now install a plugin, a network plugin, so that the Kubernetes pods be able to connect to outside world. The pods are actually use an internal network, and that network has no visibility outside the network. And this plugin, if you recall, we mentioned that during the presentation portion of the video, you need to install a plugin because by default, Kubernetes does not provide anything for that connectivity. So we need to install something. To do that, for this demo, I've chosen Calico. Is very popular. There are other plugins that you can select from. I'll provide a link in the course description so you can look at those as well, other ones as well. So let's run that. And now it's completed. So next step is, again, copy the config file that we kind of use as our authentication from the home, from this server, which is under home cube, into the next, the node that we want to now join into that cluster. So let's copy that exact same location under home. And let's just put in the password for the other server. And now it copied the config, the Kubernetes config file for authentication. So be able to, for myself, I'll be able to then connect from Kubernetes, from that server to Kubernetes. Now we need to actually now log in to the node that we want to join to the cluster. So we're going to SSH to node 1. Let me just put in my password again. And then we need to, if you recall, it gave us a command to run on the server. So now we are in node 1. And then when we run this command, let's go through that. QADM join, and that is the IP address of the master node, and that's the port number, and then it provides a token which is valid for a certain amount of time. So let's do that, run that, and that's what we need to run, as admin. So let's switch back to admin. And then we need run the command. And this time starts doing preparation for joining that node to the cluster. So the node successfully joined to the cluster. So this was completed as far as adding one node. So you need to do the same thing for other nodes that you like to join to the cluster. It's this exact same process. So I'm not going to repeat that. So right now we have one master and one node. Next step is to go ahead and do some testing to make sure that the cluster is up and running. Okay, at this point we have the cluster up and running, and we have added one more or more nodes to it. In this section we just verify that everything is working correctly. So on line 2, kubectl cluster info, let's run that. Basically gives us a basic information about verification that the master is running, and it tells us that it's running on this IP address and port number. On line 5, we can verify how many nodes we've added so far and what is the status of those nodes. Let's run that. And it shows that we have a master node and node 1. So we have two nodes altogether running, and they both status are ready. So far, so good. On line 8, we are going to do a simple deployment to make sure that we can actually deploy pods and we are able to communicate with them. So let's go through that. kubectl, create deployment, we name it hello world, -- image, and that is where the image is coming from, the container is coming from. It's coming from Google, and it's called hello world. So let's run that, and we can see that hello world was created, deployment. On line 11, we can verify that by running kubectl get deployment. So let's run that. And it shows us that hello world indeed was deployed and it's ready. So again, good sign so far. On line 14, kubectl get pods. So we want to see how many pods have been deployed so far. So let's run that. And we only have one pod that was deployed as part of our hello world deployment. That is the IP address. It is running on node port 1. On line 17, see we can scale up. So kubectl scale -- because it's equal to 2. And that is the name of our deployment. Let's run that. And it says that our service was upscaled. So we should now have 2 pods running. Let's run the kubectl get pod again. And indeed, we can see that there are 2 pods running. And those are the IP address. And as you can see, one is running on master and the other one is running on the worker node. On line 23, we want to make sure that we can expose our services to the clients. So let's go through that. On line 23, kubectl expose deployment, hello world, -- port 8080. So that is the port that is internally exposed to the clients that are running inside our cluster. -- port 8080, that is a port that is running on the pod itself, is also 8080. -- type equal to node port, and that part will tell Kubernetes that please expose a port that clients that are external to the cluster can connect to it. So let's run that, and we get confirmation that the service was exposed. Let's scroll down. And to verify on line 26, kubectl get services. Let's run that. And it tells us, yes, hello world is the type is node port. The cluster IP, that is the IP address that the internal client can connect to it, is that. And also the port number is 8080. So the client that are internal to the client can connect to our service through IP address 10.102.61.248 and port 8080. And port 31151, that is a port number that external client can connect to our service. Great. Now let's next step is we kind of verify that we can connect to our service. On line 28, we have curl HTTP, the pod IP 8080. So we need to grab one of the pods. So again, looking at the pods here, we'll see that on this one, this IP address 172.16.9.73, it's running on port 9 on a different node. So it's running on worker node, and we are running our commands from the master role. So it's a good cross node connectivity test. So let's run that. And as you can see, we get hello world, the confirmation says this is coming from our service. The service says hello world, its version number, and the host name that is running on. So Great, so we can connect from one node to the other, kind of cross nodes. Next step is to test our cluster IP. So on line 29, curl HTTP. So we substitute that with our cluster IP that was exposed. And again, it's running on port 8080. So again, it is internally. So I run and we'll see it, again, same message, because it's the same service. It's just exposed through a different port and IP address. So we can connect to the pod directly. We can also connect through the cluster IP. And next step is to test our node port. So let's grab this port number. And on line 32, curl HTTP localhost, and we're going to expose this. Substitute that with the actual port number. So basically I'm running from the master, so say curl HTTP localhost 31151. So suppose if you have a client that is running from outside, we can then substitute the localhost with the actual IP address of one of our nodes. It's load balanced, so we have two nodes. We can reach to port 31151 or service from either one of these two nodes. So let's run that. And again, we see exact same message, which basically, yes, it's connect. We can connect. So the last test to do is to actually SH into one of our pods. So let's go to, we are running for master, and this guy is running on, so let's grab this guy. So we need the name of the pod, and let's substitute it here. And let's run that. So the command is kubectl exec -it. This is the name of the pod, and then -- followed by the command. The command that we want to run is sh. So we're going to sh into that. So let's scroll down here, and as you can see the prompt. We are now inside the pod, so we can then see if we can ping the other pod from one pod to the other, again from across nodes. So we are now running inside a pod that is running on the worker node, one of the worker nodes. We can see, we can ping a node that is running on the master. So let's do that. And as you can see, successfully we can ping. So one of the premises of Kubernetes or requirement is that any pod should be able to connect to any pod on any node. So this is achieved. We just we saw that. So I think this completes our installation and configuration of Kubernetes on CentOS. We just wrap up and then end this presentation. Thank you for watching. I have other videos that might interest you. The first one, I discussed in detail how to set up Windows Terminal, WSL2, Linux, Docker, and Kubernetes with a single cluster Kubernetes on Windows 10. In the following video, I discussed how to enable nested virtualization on Windows 10 so we can run WSL2 and Hyper-V on a VM that is running VMs inside VMs. So if you want to do that, watch that video. In the following video, I discussed setting up a multi-node micro K8s cluster on Windows 10. Then in the following video, I discussed how to set up NAT or network address translation on Hyper-V, which enables you to set up a private network that you are able to network your servers together, connect them together. And then in the previous video, I discussed how to set up and configure CentOS Linux server on Windows 10 hypervisor either Hyper-V or virtual. So kind of preparing the field for today to set up our multi-node cluster. So this kind of, this video is building up our knowledge of how to manage, to create and manage a multi-node Kubernetes cluster. I will be going deep into Kubernetes internal working and support. So if you are interested into maybe getting into Kubernetes support as an engineer, I think that would be helpful for you. So if you like, you can subscribe so that you'll be notified for the future videos. Also, if you thought this was useful, please give it a like and share it with your colleague. Thank you very much, and hopefully we'll see you again soon.